Okay, so basically our learning goal today is the same as it was on Friday, except we're going to be factoring quadratic trinomials where a is equal to something other than 1, okay? So if a is not 1, we're going to have to work a little harder. How many of you thought that the factoring when a was 1 actually was probably the easiest factoring we've done? Yeah, it's the easiest of all of them. Okay, but so this isn't really that hard, it's just that it involves more steps. So now what you're going to have to do is you're going to have to be careful and make sure that you're always paying attention to that a value. Don't think that you can just do what you did for today and all that homework and you're going to get away with it, because here's what it says. When the quadratic trinomial has an a value that is not 1, you're going to use the diamond method first, just like we did on Friday, last Thursday. Except it's a tiny bit different. And then we're going to have to factor by grouping, which is why I had you warm up practicing that one I had on the board for you. So we're just going to do 3 problems together, and then I'll let you get started on your homework. Okay, we have 5x squared plus 11x plus 2. We have a quadratic trinomial where a is not equal to 1. What's our a value? 5. And our b value is 11, and c is 2. Okay, notice the difference here. We don't just put c upstairs in our diamond and b downstairs. We have to take the a times the c, which in reality, that's really what we would have been doing on Thursday, except when a is 1, 1 times c is still just c, isn't it? So, you know, I didn't waste time saying take the a value times c when a is 1. So we're going to take, let's show this so that our notes are very clear. We're going to take 5 times 2, and we're going to stick 11 down there. And 5 times 2 is 10. So we need 2 numbers that their product is 10, and at the same time their sum is 11.
10
and 1, right? Or 1 and 10. Does it matter which way we put it in there? Okay. Now, here's the difference today. If this was when a is equal to 1, we would have said, okay, our factors are x plus 10 times x plus 1. Would x plus 10 times x plus 1 multiply back to 5x squared plus 11x plus 2? No, because first of all, they both start with x. What's x times x?
X squared.
X squared. That's not 5x squared. So don't make the mistake of thinking that now you're ready to set up the factors. Instead, what happens is we are really renaming the middle term, the x's. So these are going to become x's. So 10x and 1x. Because what is 10x plus 1x? 11x. So it's going to become the new name for the 11x. So we're going to rename our quadratic trinomial as a 4-term polynomial. There's our new name for our trinomial. And now we can factor that by grouping. So we'll make, it's already all addition, so we'll just stick some parentheses in. What's the GCF of the first group?
5x.
5x. What's the other factor?
X
plus 2.
X plus 2. Okay? That's our first group's new factored name. Bring down the addition between the groups. And what's the GCF of the second group?
1.
Just 1. So 1 has to be written. And our other factor for that group is?
X plus 2.
X plus 2. What is it that we want when we're factoring by grouping?
2 things in parentheses to be the same.
And we need those binomial parts of those factors to match exactly. And do they?
Yeah.
Yes. So this is now the GCF of the whole 4-term polynomial. They both have an x plus 2, so we say that's the GCF. And no more addition sign now between our parentheses. Now we say, what's the other factor? After we
5x plus 1.
5x plus 1. This is our factored name right here. And what does it need to do? Multiply back to
The same.
what is,
original.
yeah, what we were factoring. So we're going to, you can FOIL it, you can rectangle it, you can distributive property, whichever one you like to show. And we're going to make sure that it goes back to what it started as. Sure enough, 5x squared plus 11x plus 2. It appears to check out. Okay, so basically, if you don't use this method, what you need to do is you need to figure out what would you have to have as beginning terms that would multiply to be 5x squared. What would you need to have as ending terms that would multiply to be 2? And yet, in the O and the I step of the multiplying, you would arrive at an 11x. So the method I am showing you is just a way to get to that. You can use guess and check. You can look at it and say, I already know what that is without having to do the diamond method and the factoring by grouping. But you better really know how to do it. Okay, questions? Okay, let's go to the back then and try our next one. Now, when there's subtraction involved, don't remember the deal. That means you're going to have to account for that subtraction becomes the negative on that particular term. So what's our A value this time? 4. Our B value? Negative 14. And our C value? 6. So remember, let's show this in our notes. Up, we multiply that A, which is 4, times that C, which is 6. And down we put our B value. So what is 4 times 6?
24.
24. What did we learn on Thursday last week when we said if you have a positive C value but a negative B value, what does that tell you about your two numbers?
They're both negative.
They both have to be negative. So we need two negative numbers. What are they?
Negative 2
12.
and negative 12.
Okay, negative 2 and negative 12. Negative 2 times negative 12 is positive 24, and they add up to a negative 14. So what do those become again?
Negative 2x and negative 12.
Yeah, so maybe the thing to do is circle those and off to the side here, say that is now negative 2x plus negative 12x. That's really what we're going to do with those. They are going to replace our negative 14x in the middle. So we're going to rename our trinomial as a 4-term polynomial and factor by grouping. Again, it's just a good idea to still just keep using addition, and it's okay if we have that, add the, like a plus and negative, because then it makes it better for us when we're going to factor by grouping anyway. So we're going to stick our parentheses in, because we have addition in the middle, so we can. Okay, go ahead and GCF each of these groups. Get each of the groups factored. Remember, you have to do whatever it's going to take to get those binomial factors of each of those groups to match. So sometimes that second group's GCF might need to be negative so that you make that happen. What is our factored name for the trinomial we started with?
Two x minus one. Two x minus six.
Okay, check it. Make sure. I'm gonna circle my answer and call it the factored name because mine checked out. Did yours check out?
I got a different one.
Okay, you got a different answer? Okay, what'd you get?
4x minus 2 and x minus 3.
Okay, 4x minus 2 and x minus 3. Okay, and that checked out?
Yeah, I foiled it and it came up to the same.
Yeah, that's another factored name for it. I'll tell you guys in a little bit why there can be more than one factored name for this one, okay? Anybody have a different one yet? Okay, notice something about whether it is the 2x minus 1 times the 2x minus 6 name, or it is the 4x minus 2, x minus 3 name.
The right one's divided by 2 and the left one's multiplied by 2.
Okay, so in this one, this really could have a 2 divided out of it yet. Right here, 2x minus 6, that could have a 2 out of it. This one, the 4x minus 2 could still have a 2 divided out of it. So coming up in lesson 7.6, that's one of the things we're going to learn is how can we show it factored completely, okay? So what we're going to be doing is we're going to say, is there a GCF that we could divide out before we even start this? So what could we divide out of all three of those terms to begin with? 2. And you know, here's the advantage of when you can GCF at first. If you can GCF at first and take something out, it makes it easier to actually factor what the trinomial you have left. It should be a little bit easier to actually find those. What multiplies to be this and adds up to that, okay? So 4x minus 2x minus 3 is also another good name for it. You could also have this as an answer, okay? Okay, try the next one completely on your own. Go, make that one happen. Check it. Oops, gotta identify A, B, and C first. Don't do like I just did, went right into it. Are you done, Devin?
Yeah.
Okay, come on up and do it for me, please. Thanks.
Don't we just show the first, like, the simplified one?
What do you mean?
There, it's actually
You can start there if you want.
okay.
And check yours when you're done, make sure it works. You're gonna have to do check problems in your homework. Do them now too. But if you're stuck and can't get it, you can always try and see if Devin's work up here will help you
Can
out.
I charge my phone?
Yes, that would be a good idea.
Should I show my check work too?
Hmm?
Should I show my-
No, you don't have to show your check problem.
It's very simple.
Thank you. Okay, so Devin says that when you're done, or if the factor name is this one, right? 3x minus 5 times 2x plus 3. Okay. Anybody get a different factor name? Do you think we could?
No.
Why not?
There's nothing that you can divide out.
Yeah, there's nothing in the beginning that could be GCF'd out, is there? There's nothing that goes into 6 that goes into -1 that goes into -15. Other than if you went crazy and decided to factor out a -1 for some reason, if you did that, then of course the factors would look different, but typically we don't necessarily factor out -1s unless we want to make our A value positive. Okay, so anybody have questions? This is what you have to do with the 11 problems that you have for tomorrow. And remember, one of the things that's really important that is going to get you guys in trouble is if you don't remember that if this sign right here in the middle of your groups, before you put those parentheses in, if that is subtraction there, you can't just stick parentheses in. It has to be addition to be able to stick the parentheses in, right?
Yeah.
What do you suppose, what's the reason I'm having you do check problems? To make your homework longer?
No.
Then what would be the reason?
Make sure you get the right answer.
Make sure you get the right answer, and if you don't, what should you do? Go back and rework it. You only have 11 of these to do. I'm not asking you to do 25 of them. I'm asking you to do 11 of them and do them correctly the right way from the beginning so that you're learning it, because we don't have 3 days to spend on this, okay? So questions anyone?